And then I would like to introduce our first speaker after the break, who is Ashok Sridhar. Ashok is a regular speaker at the Brabant Innovation Days at several occasions. He used to work for TNO Hall Center. He started his own new company in manufacturing printed electronics. It's located in Eindhoven. And well, you're scaling up great ideas from the lab to the market. So Ashok, please tell us more about it.
My name is Ashok Sridhar. I am the CEO and one of the 3 co-founders of TracXon. Before going to the core of my presentation, I would like to introduce TracXon to you. So TracXon, as Yurik just mentioned, we are a spin-off from Hall Center TNO. Of course, we have had 2 excellent talks by TNO Hall Center colleagues. We were spun off from Hall Center last year with the aim of taking Hall Center technology in printed and hybrid printed electronics from a lab scale to a production scale. So we are a fully integrated foundry to manufacture printed electronics and hybrid printed electronics. We are about 20 FTEs right now, and we are growing to 30 people already in the next couple of months. So for a startup, we are scaling up pretty fast. Our core expertise lies in roll-to-roll and sheet-to-sheet printing of electrical circuitry, but also on assembling components, SMT assembly, on such printed circuitry in different sizes, right from a very small PCB to a very large roll-to-roll printed circuitry. And with this, we are ushering the transition of printed electronics and hybrid printed electronics from a lab scale to a production scale, thereby revolutionizing the way PCBs are manufactured. And let me also touch upon briefly, what do these terminologies mean? Printed electronics is nothing but printing of electrical circuitry, typically on flexible substrates, for example, polyesters, polycarbonates, even rubber, sometimes paper. And when we assemble components such as LEDs, chips, passives, and so on the printed circuitry, it becomes hybrid printed electronics. You can compare this with, for example, PCB, that's printed electronics, and PCBA, PCB assembly, that is hybrid printed electronics. What does it offer? By additively manufacturing the circuitry and the entire device, it is possible to make them large area, flexible, stretchable, even 3D formable. And of course, since it's fully additive, there is no chemical etching involved at all. It also results in low energy consumption, low carbon footprint, even the use of bio-based substrate materials that are recyclable, paving the way for sustainable electronics. And this is the message also TracXon CTO Corné Renthrop reflects in the following video.
At TracXon, we foresee a future where we partly replace the printed circuit board industry of electronics to something that's more flexible and printed. If you look at this is a rigid material, cannot bend, in which the circuitry is plated and then etched to create the electrical functionality. We replace that by printing, and printing is done as an additive way. So we add what we like and what we need. We do not subtract. Then we create vias and bridges to make a real functional circuitry, and the electrical components are then placed on top of this material. So as you can see, this is not rigid, this is flexible. It is even, in a certain version, stretchable if we print on, for example, rubber-like materials. The good thing is also, because it's printing, is that we can do it on a very fast manner and on a roll-to-roll. So rolls like this, 60 centimeters wide, can be printed at very fast speed, like you print stickers and display materials. The benefit of printing is that it's very material efficient, but also energy efficient. The energy needed to print is about 12 times less than of printed circuit boards, which is actually verified by the Vrije Universiteit van Amsterdam. Next to that, the materials that we used can also be recycled. The materials are in sense meltable, also the metals, so we can completely, at end of life, dismantle the products and bring them back to their original states, which cannot be done by printed circuit boards either, which actually end up in landfill or are incinerated.
Now moving on, what does TracXon do as a foundry? We leverage our expertise to manufacture for B2B customers in different domains as seen here. Digital signage and lighting, automotive human-machine interfaces, so touch panels, also in-mold structural electronics, health and wellness sensors, and IoT devices. Of course, you can also think of smart buildings and smart cities and so on and so forth. And why are we able to do this, and what's the differentiator? Because we originate from TNO and Holt Center, we carry forward, in total, 300 plus years of research within that institute, but also TracXon's own employees cumulatively have more than 100 years of experience in this field, which makes us a small but a very strong team, which is a right mixture of R&D capabilities and manufacturing capabilities. Now, I'll move on to the core of my presentation, mass manufacturing of printed electronics using roll-to-roll technologies. First, it's important to understand why roll-to-roll processing is needed. Why not just sheet by sheet, like they make in the PCB industry right now? That's because several emerging applications require roll-to-roll manufacturing. Let's take the example of wearable devices, health patches, for example, to monitor the vital signs. These are foreseen to be made in tens of millions, even hundreds of millions per year. But the electronics alone is not the full device. One needs an electronic layer, but also there are a lot of conversion processes afterwards, like, for example, application of non-woven textile, lamination of an adhesive film. So all these post-processing activities happen in a roll. So it's important to produce and supply electronics also as a roll. That's one of the main reasons. The second one is products that require large area functionalities that require seamless electronics. For instance, we have customers in the domain of smart buildings or also automotive glazing who want let's say, an LED film or also heaters without any segments. So basically one film of 2 meters long by half a meter wide, all with electrical functionality and almost semi-transparent. That's not possible with current PCB manufacturing. And last but not least, purely for economies of scale. As you can imagine, if one can print at 10 meters per minute of electrical circuitry, it is possible to produce tens of millions of products per month, thereby leveraging large economies of scale. These are some of the reasons why roll-to-roll manufacturing is important in electronics. Now, I think I have a video next, but before that, there is, of course, a slide, and then there is a video. This slide kind of captures two most important machines at our facility. To the left on the slide is a roll-to-roll printing machine, fully integrated inline, which means it can print, cure with UV, near-infrared, or convection thermal heating, depending on the type of ink you want to print. This line can print conductive, dielectric, resistive, sensing, but also graphic inks. So one system that can do all. Coincidentally, this was customized and made for us by a Japanese company based in Gifu. It's called Sakurai Graphic Printing Systems. This is only one of its mission of its kind in Europe, and we are proud to have this. And this line, as I mentioned already, can print at more than 10 meters per minute with feature sizes as small as 75 microns. So high speed, but also high accuracy. To the right on the slide, you see what happens after printing. So the printed circuitry alone is not sufficient. One needs to assemble components, LED strips and whatnot. That's a large area assembly machine that's also unique of its kind, on which we can assemble electrical components to create fully functional systems and foils. Yeah, that's the printing line in a clean room, ISO 8 clean room. That's the roll of foil, typically polyester or polycarbonate, even rubber. That's the printing unit. It's a stop-and-go process, can print at very high speed. After printing, it goes into an oven. Depending on the ink, we can switch on UV, infrared, or convection oven. This is a convection part, can be up to 30 meters long. By the time the foil comes out on the other side, the wet ink is fully dry, and then it's a fully functional electrical circuitry. That's like magic, like printing of newspapers. And this foil is now wound back. It's done. This is electrical circuitry. If you want to print the next layer, then you bring it back, change the mask on the ink, print the second layer, and so on and so forth. This is our assembly area, a part of our assembly area, where on the printed circuitry, components are assembled. As I mentioned, chips, LEDs, and whatnot. And can be done in a very small size, but also in a full roll-to-roll setup. And there are many other equipment, including post-processing machines. For instance, laser cutting. You can actually make the products into individual pieces before we ship to the customers. So some of these products you see on the screen, it's also here. I have a small table over there in the next room. You can come by and have a look at what we have done so far. Yeah. That's the video. Now, Without saying too many words, I would like to show the next 5-6 slides what are the product possibilities. I have to emphasize that TracXon is not creating its own product. We are creating products for other customers, as in the customers come with the design. We actually optimize the design, we make prototypes and pilots, and then go to full-scale manufacturing. And some of these examples are not confidential, so I'm allowed to show them. Hopefully the videos also play here. Yeah, that is a wearable patch for vital signs monitoring. It can monitor heart rate, breathing rate, and so on and so forth. This is based on whole-center design. On the right, you see a spinal health monitoring sensor. It's a long, thin sensor that can be integrated in a shirt and continuously monitor posture of the spine for spinal health. I mean, spine is literally the backbone of life, so one need not have to wait until something is damaged. By monitoring the posture and giving a feedback via the app, you can always have a better posture, and that helps a lot. And that was made for a German company called Mingtech. This is an example of product possibilities for health and wellness. Moving on to the next one. This is IoT, Internet of Things sensor. In this particular case, it's for sensing, but we can also make IoT devices for logistics and tracking. For example, high-value pharmaceutical items, vaccines, and so on, can be tracked with IoT devices. This video hopefully plays as well. Yeah. This is a multi-layered printed circuitry, fully additive, on which microprocessor, a lot of passive components, but also an NFC chip is added. You can also see, I don't have a pointer, you can also see the NFC antenna around on the periphery that's also additively printed. So there is no etching here. It's all fully printed. That's an example for the IoT domain. And then possibilities for automotive, it's many, many possibilities. One of the examples, one of the projects we are starting, of course, we are not allowed to show the full design. This is just a digital mock-up. Automotive sunroof. Many cars have sunroofs, and sunroofs, the function is, of course, to let the sunlight in. But during the night, the automotive OEMs want a starry sky effect, but also high-intensity reading lights, all in the glass, or also a touch button to activate them. So basically, if you look carefully, there are many, many, many small LEDs. These are typically micro LEDs. My colleague Gary presented in the morning. Almost invisible lines, but there are also high-power LEDs, high-brightness LEDs. 4 of them you can see, like kind of comets or meteors coming in the sky. They are for reading lights, basically. So in a single foil, decorative lighting, reading light, but also touch function can be integrated and laminated between 2 glasses in an autoclave process. So this is a classic example why large area roll-to-roll is required. This is not possible with traditional PCBs. Another example for automotive are human-machine interfaces, HMIs. For example, the entire dashboard can be replaced with functional plastics, or so-called in-mold structural electronics. And this enables the so-called dumb plastic parts to become smart. Not just that, it can also enable semi-transparent displays and signages, as you can see in this video on the right-hand side. Yeah, now there is a touch button, someone is actuating, and then you see that a lot of micro LEDs light up, but you can still see through, basically, that glass. And this enables also many, many applications in automotive glazing, but also in smart buildings and so on. Speaking of smart buildings, we are also working on a project with a customer in Europe for integrating advertising LED foils for skyscrapers. I mean, cities like here in Tokyo, also in Hong Kong, Shanghai, whatever, New York, there are so many skyscrapers full of glasses, and there is a trend towards having advertising embedded in the glass. And of course, that should not disturb the people living inside or working inside the building. So the trick is to have almost a semi-transparent film, which from the outside combines to form a whole advertising in one side of the building. So this is another example of what is possible with LED foils with semi-transparency, partially see-through, partially occupied by LEDs. This is one of the last examples. Again, it doesn't have to be transparent all the time. It can be with a lot of LEDs. Here's just an example of what is possible. You can already see the form factor. It's not an LED strip that you can buy in a shop. It's an LED surface, and this can be wrapped around a pillar or around or embedded in a wall or whatever. I'll play a video again here. You will see an example of LED foil device for signage applications. I think this is about the last example I wanted to show. This is from our parent company, Whole Center, the design-wise. This shows a large area sensor, a sensor mat. In this example, it is piezoelectric and piezoresistive inks printed additively in a flexible foil or a stretchable foil. This can be used, for example, to monitor posture, movements, and so on, even heart rate, embedded in a chair or in a mattress. So TracXon is capable of upscaling these mats for mass manufacturing. And you can also think of other applications, for instance, inventory management in shop shelves. If you go to the supermarket, there are many, many shelves with products. And there, if every shelf has these sensor mats, if someone picks up the product, it recognizes which product has been picked up and gives a feedback to the inventory management system. So this is another application of what is possible. Or one other possibility is to have some of these simplified mats integrated in carpets, so it can monitor people's traffic, so to speak, how many people are going into the hall, how many people are exiting the hall, so for big data-like applications.
The second hall is a so-called SMT assembly hall, where components like chips are assembled on top of the printed circuitry. That hall has ESD flooring to make sure that the components are handled in a safe manner, and is also a clean room. It is very important to have electronics everywhere. This is happening. There are companies and concepts talking about trillion sensors, trillion PCBs. Nobody is going to stop that because, yes, electronics are very helpful. But if all these end up in graveyards of electronics where all the metals and all the non-recyclables are stuck, you have to either burn them or bury them under the ground, literally sweeping under the carpet. But the future vision of TracXon is to be able to use fully bio-based substrates, and also all the components and metals that go on top, we want to explode into individual components and recycle them separately. We want to achieve in 10 years true cradle-to-cradle manufacturing.
We would like to strive for being the TSMC of printed electronics. TSMC, as you all know, is the abbreviation for Taiwan Semiconductor Manufacturing Company. It's a multi-tens of billions of dollar revenue company in Taiwan. And when they were set up a few decades ago, they changed the way chips were manufactured. So TSMC has a lot of design expertise, a lot of process expertise. They get access to the best machines in the business, first access, so to speak, including that of ASML, which is from the region of Eindhoven, Brabant, the leading provider of chip manufacturing equipment in the world. So because of this expertise, they can be an independent pure-play foundry and make chips for many different companies. So the companies, the fabless companies, come to TSMC to get their chips and designs manufactured. And sometimes they're even competitors, but TSMC is making sure there is no leak of confidential information. There's a pure play foundry. And that's exactly what TracXon is becoming for printed electronics. Of course, we are small in scale with a lot of ambition. We have a lot of know-how in terms of design rules, how to design for printed electronics. So we can co-design with the customer. Then because of continuous process innovation and own process IP, we're able to implement advanced manufacturing techniques to manufacture in large area, but also very fine resolutions at the same time. And the third point is the most important. We offer manufacturing services. End of the day, we want to manufacture these devices, starting with the thousands, going towards hundreds of thousands, eventually in millions, so that the customers can go to the market with that. And all with very secure and integral environment, so no IP leak. We'll never compete with our customers. So we are also a pure play foundry for hybrid printed electronics and printed electronics. This is the last slide. What is our concluding message? Well, the graph to the left shows the size of the PCB industry. And already if you look at current status, 2023, it's about $86 billion in size. And there is no sign of slowing down. Within the next 8-9 years, it's going to go to $141 billion. In fact, there are certain trends that predict trillion IoT sensors per year to be produced. Trillion sensors per year. This is unbelievable numbers. At the same time, the graph to the right also shows a shift towards multi-layered and complex PCBs. So not just simple ones, single-sided, but double-sided, multi-layered, and so on and so forth. So PCB industry is growing all the time. Trillion sensors are going to come, but also the complexity is increasing. Imagine producing all this with the current technology. Etching, a lot of chemicals, almost not recyclable, poor form factor, very big CO2 footprint. This is a no-go. Hence, I think we should work as an ecosystem together to realize this growth, not by traditional PCB manufacturing, but by printed electronics and hybrid printed electronics. This way, we can create a more sustainable environment. And this way, we can create a positive footprint for the next generations, not carbon footprint. So with this message, I would like to thank you for your attention, and also to, of course, the organizers for inviting us here. A pleasure to be here. Thank you so much.
Well, thank you, Ashok. Very interesting to see and to listen to the projects you're currently working on, even more like on the different application fields for the future. Maybe you can share with us more about the kind of partners you're looking for, also like here in Japan.
That's a very good question. Actually, if I take a step back, I used to work, as you mentioned, in total for 8 years at Whole Center. And Japan has always been one of the strongest countries in terms of having partners from. So many companies from Japan worked with Whole Center. And the trend is continuing, actually. So Japan has a lot of innovative companies in terms of applications, but also in terms of materials. Yeah. So we would like to collaborate with the entire ecosystem, because together we can capture, as I showed in the previous slide, such an enormous growth possibilities while not damaging environment. So this is the right country to be in. Material suppliers, machine builders, but also end product manufacturers. We're open to talking to all of them to see how we can collaborate.